Okay, Assalamualaikum guys and good day everyone. Okay, so yeah, I'm sorry because I'm being late update this video for this week. Okay, but I hope that you still have a time lah for this weekend to study all this video. Okay, alright, so class, so basically for today we are still in chapter 2. Okay, alright, so and this is the last topics in chapter 2 that you should learn, that you should know. Okay, the topic is about application of multiple integral. Okay, application of multiple integral. So you have learned before double integral and also triple integral. So now we will learn the application that we can apply for the topic double and also triple integral. Okay, so I will list down the formula. So they have a lot of formula for this chapter, so I will list down first. Okay, but before that I will divide it into two. Okay, the first one is that involve with double integral. Okay, and then the second one that we involve with triple integral. Okay, so I will list down the formula. Okay, the first one that we will learn, or the formula that you should know here, is density. Okay, density. So this is the symbol for density that we will use, and the formula for density is equal to mass over area. Okay, this is for double. Okay, so now I go to the triple. So same thing. Okay, it's still a density. Okay, but the formula now it will be different. Okay, so it's still mass, but now it's will over volume. Okay, class. So the difference here is on this one, because we know that double integral, we use double integral to get a area, is it? And for triple integral to get a volume. Okay. Okay, then what else? We will calculate next is mass. Okay, because from here we know that we need to know, we need to have a mass. But how to calculate mass? Okay, mass we denote as SM. Okay, how to get M? So for double integral, of course, it's just a double integral here. Okay, so we will integrate density. Okay, so integrate density, we will get mass. So same thing for triple. Okay, so for triple, we will triple integrate. Okay, triple integrate density x, y, z, of course, with respect to dv. Okay, A here is stand for area lah, means that dx dy, and V here is stand for volume, so dx dy dz. So the sequence dx dy is it's up to you. You want to do it dx dy or dy dx, is up to you. Okay, alright, so now we settle on these two. So we have another one, not another one, we have still a lot. Okay, so for number 3, we call it as a first moment formula. Okay, first moment formula. So sometimes it call it as first moment lamina. Okay, first moment lamina. Alright, okay, so since this is a double integral, so they have only two. Okay, the first one is my. Okay, this one means that it's about y-axis. Okay, when the question asks you to find the first moment lamina of y-axis, so means that it's my. So the formula here is x and then density. Okay, class. So okay, see carefully. This is my. Okay, it's about y-axis. Then what the formula here is x. Okay, it's contradict. Kalau sini, if the question asks y, means that the formula inside here must be x times density. Okay, how about if mx? Mx means it's about x-axis, so means that it will be y times density. Okay, so you can see the difference. Okay, so it's easy for you to memorize it. Okay, so how about triple. Okay, first moment lamina for triple. Okay, alright. First moment lamina for triple. So since for double we have two, because of we just have only two axes, x and y. So then for triple we know when we will have three because it's a triple, right? So moment about xy plane. Okay, it's different. Okay, we will use, okay, I just write down first. Okay, for this one we just have my because we just only have two axes, y and x. But for triple we have three axes. Okay, z, y, x for example. Okay, so means that if the question asks you to find the first moment, it will be asked like this: first moment about xy plane. So xy plane. And we also have the first moment of xz plane, and the last one is a first moment for yz plane. So it's different. Okay, it's different between double and triple, but the formula is quite similar. Okay, of course lah, they have different on the triple integral here. Okay, so here, okay, back to this one. So if here is y, so that's mean here as x, right? So now here is xy, so that means it will be z. Yes, it will be z. Okay, so here xz, so here that means is y, and then the last one is yz, so that means here is x. Okay class, easy, right? Okay, so this is how we want to memorize it. Okay, so then what's next? Okay, we have also another one, we call it as center of mass. Okay, center of mass we denote as x, y. Okay, x bar, y bar lah. For triple we denote as x bar, y bar and z bar. Okay, how to get x bar and y bar and so on? Okay, for x bar, for double integral, okay, so the formula here is my over m. Okay, can you see here this one x bar, so that's why, and that's mean here is about y axis. Okay, because of what? Okay, if you can refer back to this formula, so here is x, okay, that's why is my. Okay, my. So my you get it from this one, which is this first moment. How about m? M is a mass. So you will find out these two, then you combine into this formula, you will get your center of mass. Right? Okay, now the last one, the y prime, the y bar here is mx. Okay. Right? Okay, now for triple integral also the same thing. So x bar, y bar and also z bar. So if x bar, it will be myz. Okay, myz, this one, because they have x here. Alright, so divide by m, still divide by m lah, divide by mass. Okay, then for y bar, m at z. Okay, divide by m, and the last one z bar is m x y divided by m. Okay class, so this is the center of mass. Okay, another one is related to center of mass. Okay, center of mass sometimes is called as center of gravity. Okay, so now we also have another one that we call it as centroid. Okay, this is number 4. Okay, number 5, centroid. Okay, centroid means it's a center of mass. Okay, centroid actually is a part of center of mass when your density is equal to constant. Okay, I repeat again. Centroid is a part of, centroid is a center of mass when your density is a constant. That's it. So when you get density is constant means number. Okay, constant means a number. So when you get the density is constant, therefore your center of mass is automatically named as centroid. Okay, so this is the formula to get a centroid. 1 over area. Okay, 1 over area. How to get area? Okay, you should know already. For double integral means you just find out double integral function is 1. Okay, and then double integral x dA. Okay, and then for y bar, okay, because it's still x by y bar, because this is a part of center of mass z. Okay, so 1 over area is a y dA. Okay, so now how about for triple? So x bar, y bar, and z bar, so it will be equal. Same thing, but it's a volume. Okay, it's a volume, class. Okay, alright, so then triple lah, triple integral. Okay, x dv, y dv, and also z dv. Okay, done. Alright, class. So now we go to the last formula, which is second moment. Just now is first moment lamina, is it? So now it's a second moment. Okay, second moment lamina, or sometimes we call it as inertia. Okay, inertia. Okay, alright. So the formula for the double integral is Ix double integral, okay, y square times with density. Simple. It's just the difference here is on here. This one is y square. Okay, if your what we call the first moment lamina is only y. Okay, y and then time with density. But now it's a y square times with density for Ix. Okay, because we call as initial, so we denote as Ix. Okay, then Iy x square density dA. Okay, alright, and then we also have something like this. Okay, if we get, or if we what you call Ix plus with Iy, which is initial x times plus with initial y, it will be get initial at origin. This one is about x axis, this one is about y axis, and O here is stand for origin. Okay, so this is just something like that, the fact that you, yeah, the extra information for you guys. Okay, alright, so now the last formula for triple integral. Okay, we have Ix also, and then triple integral. Okay, so here is x, so that's mean here should be y square plus z square, because this is triple, is it? Triple, so means that if you close x, so they have another two variables that will be available, which is y and z. So must be y square plus z square, and then times with the density. Okay, so Iy x square plus z square, and then times with the density, and then Iz, okay, x square plus y square times with the density. That's it. Okay, so these are the formula that we involve in this topic for this week, and we call it as the application of the multiple integral. So in the next video, I will show you a few examples how to answer the application of multiple integral. Okay.